All right, so far what you've seen is that you can use that block on the periodic chart and you can tell that this number is how many grams in 1 mole. And then you also know that that's how much 6.022 times 10 to the 23rd atoms of carbon will weigh when you put them on a scale. That's the mass of them. There's a number up top. Remember, that is the number of protons. That's what gives us that it's carbon. We're going to give you one more relationship. I like to talk about this as kind of like taking a molecule and going within it. It's a mole relationship, and this is kind of the bridge to the next chapter. So I've drawn a picture of a molecule over here on the left, and I color-coded it so you can see that the yellow C's, they're all the same, and then the blue H's are all the same. This is all bonded together with bonds, and I know we haven't learned about bonds yet, but that's what these lines are. They represent atoms that are kind of like stuck together. They come as a unit. They don't come as parts. They all come looking like this, all stuck together. So when it's all stuck together like that, we call it a molecule. It's a big old molecule of it. Molecule is just a way to represent one of these things, one of those units. If you look at it, one molecule, if you count up the carbons, contains 6 atoms of carbon and 12 atoms of hydrogen. So that's one way that you can use more conversions, is you can say, if you know that you have, 6, that implies that there have to be 6 atoms in one of them. And if you have H12, that means that in, again, one of them, there has to be 12 atoms. So you can turn a molecule into atoms. I'm going to take this one step further before we practice it. You can also scale this up. So let's say that we're talking about a mole, which is this many of those molecules. Of course, I can't draw a mole. There's so many of them, but can you kind of zoom and imagine that there's a mole's worth, that there's 6.022 times 10 to the 23rd in this circle. So we're talking, we're going to be talking about a mole. So if we're talking about a mole's worth, remember that there were 12 atoms of H, 12 atoms of H per molecule. And we know that there's this many molecules because we got that many molecules. And again, there were 6 atoms of C in that many molecules. So here's the big step. We can say that 1 mole of this, 1 mole of this, contains 12 moles of H, because this is 1 mole. And then remember that there were 12 atoms, and this is a mole. So for every mole, there were 12 atoms. So what we're trying to say is that in 1 mole of H, we can just immediately say that there are 12 moles of H, and in 1 mole, that there are 6 moles of C. And if you want to just make it quick on yourself and not understand like every little part of it, basically what you can do with moles is you can take 1 mole of the big thing, and then just this little number, you can use that number to talk about the individual parts. So let's see this in practice in a problem. First of all, in 1 molecule, how many atoms? So this is just looking at one of those guys. It's like saying up here, we're looking at one of those. How many atoms of C? There were 4. How many atoms of H? 8. Okay, now we're going to scale it up. In 6.022 molecules, which is a mole, there are 4 moles of C, and there are 8 moles of H. Now you do this one. Make sure you've got the concept. And then we're going to use the factor label. So once you've practiced writing those ones in, you're going to use factor label, unit version, whatever you want to call it, to figure out how many moles of S are in 1 mole of CS2, and also how many moles of H are in 6 moles. So we already have it set up. You just have to fill in those little numbers, that little relationship, and do the math. And it's the same as all of these relationships up here.